So today we are going to start our second session on object-oriented programming language. Here we are going to learn the basics of object-oriented programming language, and we are going to learn some examples which are nothing but the applications of object-oriented programming language. So before going to start this session, we will first recall our previous points, which is nothing but why do we need object-oriented programming. So object-oriented programming was developed because limitations were discovered in earlier approach to the programming, which is nothing but procedure-oriented programming. So we already learned the difference between the procedure-oriented programming and object-oriented programming language. So here I just listed few points in a difference where why object-oriented programming comes into the existence. So now let's understand what we mean by objects. When a program is executed, the objects interact by sending messages to one another. For example, if customer and account are two objects in a program, then the customer object may send a message to the account object requesting for the bank balance. So each object contains data and code to manipulate the data. So objects are the basic runtime entities of an object-oriented system. They may represent a person, a place, or any item that the program must handle. Say for example, I define here an object which consists of data members and member functions. So object I define here a car. A car has a data members. Say for example, it has a model number, year of manufacture, color of that particular car. So that comes under data members. And if I consider member functions, then it is nothing but start, move and stop. So what are classes in object-oriented programming language? Classes are user-defined data types and it behaves like built-in type of programming language. Object contains code and data which can be made user-defined type using class. Objects are variables of the class. Once a class has been defined, we can create any number of objects for that class. A class is collection of objects of similar type. So if I want to create object of a class, I have to use following syntax. First we have to write down the class name, and then afterwards we have to write down the object name. Here class name is a class which is already created. Object name is any user defined name. For example, if student is a class, then I have to write student is a class name, Ram, Sham. These are all called as objects. So in the above example, we have to create object of a class student. We can create any number of objects for a particular class. So in this slide, I have mentioned the difference between the class and object in object-oriented programming. Basically, class is a data type where object is an instance of the class. It generates objects where object it gives life to class. In class, it does not occupy memory location, where in object it occupies the memory location. In class, it cannot be manipulated because it is not available in memory, except we have given some static class. But in object, it can be manipulated. So object is a class in runtime. So now let's start with our today's session, which consists of object-oriented programming features. When we consider object-oriented programming, then it encompasses of four basic types, which consist of encapsulation, inheritance, polymorphism and abstraction, where we have to see what you mean by method overloading and method overriding in object-oriented programming. So encapsulation is a feature of object-oriented programming language. Encapsulation is the mechanism which binds code and data together and keeps both safe from outside interface and misuse. Encapsulation is a protective cover that prevents the code and data from being accessed by other code defined outside. This is nothing but the process of wrapping up of data, which is nothing but properties, and behavior, which is nothing but methods of an object into single unit. In plain English, if I want to explain the encapsulation, that means to be enclosed in as it is in a capsule. So, encapsulation is the first pillar or principle of object-oriented programming. In simple words, encapsulation is the process of binding. What we want to bind here? Data members, which is nothing but variables or properties, and member functions, which are nothing but methods, into a single unit. If I want to give the example of encapsulation, then class is the best example of encapsulation. So in this slide, I have mentioned one example of encapsulation, which is nothing but medical store. Let's say you have to buy some medicines. You go to the medical store and ask the chemist for the medicines. Only the chemist has the access to the medicines in the store based on your prescription. The chemist knows what medicines to give to you. This reduces the risk of you taking any medicine that is not intended for you. So, in the above example, medicines act as member variables, chemists act as member methods, and when we consider a person who are going to buy that particular medicine is an external application or piece of code. Through encapsulation, data is not accessible to the outside world, and only those functions which are wrapped in the class can be accessed it. Encapsulation solves the problem at the implementation level. That means a class can specify how accessible each of its member, which is nothing but variables, properties and methods, is to code outside the class. So, encapsulation means hiding the important features of a class which is not being needed to be exposed outside of a class and exposing only necessary things of a class. Here, hidden part of a class act like encapsulation and exposed part of a class acts like abstraction. The abstraction is the next property of an object-oriented programming language. Abstraction specifies necessary and sufficient descriptions rather than implementation details. Abstraction is an essential element of object-oriented programming. Through abstraction, we can manage complexity. Abstraction means hiding the unnecessary data from users. Abstraction defines only the essential characteristics of an object. Abstraction refers representation of necessary features without including more details or explanation. So here we have to understand the concept of data abstraction. Data abstraction is a programming and a design technique that relies on the separation of interface and implementation. So here in this slide I have mentioned the example of abstraction with the help of keyboard. When you press a key on your keyboard, the character appears on the screen. You need to know only this, but how exactly it works based on electronically is not needed. This is actually the definition of abstraction. This is another simple example of abstraction I have mentioned over here. When you see or when you use the remote control of your TV, you do not bother about how pressing a key in the remote changes the channel on the TV. You just know that pressing the plus volume button will increase the volume. So let's start the next important features of object-oriented programming, which is nothing but inheritance. So inheritance is the method creating the new class based on already existing class. The new derived class is called as subclass or child class. The existing class is called as a parent class or superclass or base class. Inheritance is the process by which one object acquires the properties of another object. So the inheritance is the mechanism of deriving a new class from an old class is called inheritance or derivation. The old class is known as base class while the new class is known as derived class or subclass. The inheritance is the most powerful feature of object-oriented programming. This is a simple example I have mentioned in this slide about the inheritance. Consider an example of family of 3 members having a mother, father and son named Jack. Jack's father tall and dark. Jack's mother is short and fair. Jack is tall and fair, so he is said to have inherited the features of his father and mother respectively. Through inheritance, we can achieve two benefits. One is through effective use of inheritance, you can save lot of time in your programming and also reduce the errors, which increase the quality of the work and productivity. So there are different types of inheritance are present in object-oriented programming. Single inheritance, hierarchical inheritance, multiple inheritance and multi-level inheritance. We will explain all of the above in details later when we cover the inheritance, but today we will see some example of all these types. So now next property of object-oriented programming is polymorphism. Ability to change form is known as polymorphism. Polymorphism means many forms. Method overloading, method overriding, interface are the example of polymorphism. So let's understand the polymorphism with the help of this simple example. Polymorphism is a Greek term which means ability to make more than one forms. For example, plus is used to make sum of two numbers as well as it is used to combine two strings. So here this is to be known as operator overloading because same operator may have differently on different instances. So in the first part I have mentioned here in the example it will be used for addition part and the second plus operator is used for string operation. Or you can consider as for combining two strings we are using plus sign or plus operator. So in the polymorphism we have to understand the concept of overloading. The same method name which is nothing but method overloading or operator symbol which is nothing but operator overloading can be used in different content. In method overloading, multiple methods having same name can be appear in a class but with different signature. Say for example, sum is a method which may a function may takes 2 arguments or 3 arguments. So sometimes in a sum method I pass 2 arguments or sometimes I can pass 3 arguments. So that is nothing but method overloading. If we consider overloading using the plus operator, then it is called as a operator overloading. The plus operator can be used for addition as well as string concatenation. This is another example of polymorphism where single function draws a different shape objects. Say for example, here I define a shape with a draw function, then it can be used to draw the circle, it can be used to draw the triangle and it can be used to draw the sphere. So let's understand the benefits of object-oriented programming, or we can consider as advantages of object-oriented programming. In object-oriented programming, user can create new data type or users define data type by making the class. Code can be reused by using the inheritance. Data can be hiding from outside the world by using encapsulation. Operators or function can be overloaded by using polymorphism. So, same function or operator can be used for multitasking. So in this slide, I have mentioned few more benefits of object-oriented programming. Object-oriented system can be easily upgraded from small system to large system. It is easy to partition work for same project. Message passing techniques make communication easier. Software complexity can be easily managed. Maintenance cost is less and it is very simple to implement. Now let's understand areas for application of object-oriented programming, or we can say some examples on object-oriented programming. Real-time systems comes under object-oriented programming. Simulations and modelings, these are another example of OOP. Object-oriented database, hypertext, hypermedia and expert text, AI, artificial intelligence and expert system, neural network and parallel programming, decision support system, office automation system, CAD/CAM system. These are all application of object oriented programming.